Hey everybody, welcome to video two. Again, I wanted to separate these topics a little bit. This is just a chance to revisit how do rational functions even connect to something that's tangible, something that you can kind of understand from the world around you. So on page 458, I've actually whited out their work so I can talk you through it and kind of understand what this would look like, and you'll get a chance to try it in the homework as well, but really diving in and understanding where these different pieces come from. So a common business application with rationals is the average cost per unit or per item being produced here. So average cost per unit. So we don't know how many we're going to produce, so that's why that's our variable x, the number of units, and we can kind of go through this. So example B, we've got a recording studio. Fixed cost of $18,000 to lay down tracks for a new album. This includes studio time, equipment, musicians, etc. It costs $1.20 to make each CD. So again, these are all born out of the functions we've seen before. So really, we're just writing a linear function here to start with. So how much does it cost to make the CDs? Well, $1.20 for each CD, so 1.20x, plus those fixed costs of $18,000 altogether. But then how do we get the average cost? We have to divide that total cost. So this is the cost, C of x. The average cost would have to be then divide the total cost of C of x divided by how many CDs we make. Well, how many CDs do we make? We don't know. It's x. So we're dividing by the variable. It creates a rational function. 1.20x plus 18,000 all over x. And what's kind of neat here is we can use the analyses we've been developing over the last week to help us here. So the vertical asymptotes, for example, that's where the denominator equals 0. The denominator here equals 0 only when x is equal to 0. The horizontal asymptote, I've got to compare the degrees of the top and the bottom. Linear on top, linear on bottom, they're the same degree, so it's the leading coefficients. So y equals 1.20 over 1, so y equals 1.2 is my horizontal asymptote. And the domain within the context of the problem, then x is the number of CDs, so x has got to be bigger than 0, and also x must be whole numbers or integers. I'm not going to have 1.5 CDs, 1.3 CDs. I'm just going to have those nice numbers, 1, 2, 3, 4, 5, 6, etc. So let's now take this function, 1.20x plus 18,000 over x. You can use Desmos to graph it. I'll also show you that graphing it by hand and just then interpreting what it looks like. So clearly, since x is bigger than 0, I'm only going to be graphing in quadrant 1. To understand what that cost looks like, I don't need to worry about negative values, and so that's a nice big relief. You can turn your page to page 459 to complete the analysis here. So we're picking up here on page 459. Again, we just talked about where that function 18,000 plus 1.2x divided by x comes from. We decided to analyze this by looking at different values of x. What if I made 100 CDs, 200, 500, 1,000, all the way up through 2,500 CDs? I could take those x values, plug them into my a of x function, and the output would be as follows, 180, 120, all the way down to 840. You can definitely practice with that if you want. Once you create a scale of this, you can start to plot those individual points here. We see that shape of the curve. Notice I am not connecting this curve here because in reality, I have to make whole CDs, right? I can only make 1, 2, 3, 4, 5, etc. So I'm not going to go ahead and do that. Does it look like I've got an asymptote vertically at x equals 0 that I would be approaching? Yes. The horizontal asymptote we talked about. Okay, so let me draw those couple of things here. We had that x equals 0. For the vertical asymptote. My horizontal asymptote was y equals 1.2. That's going to be awfully tough to see here because it's so low down, but it's definitely possible that that exists in our graph. So let's talk about just what do these things mean. Y, the domain of a of x, is only those discrete values. Again, we can't have partial CDs. No partial CDs. And then again, can we use this function that we've created to answer some questions? So on number 5, what is the average cost per CD? So that's A of X. If the studio purse is 10,000, so A of 10,000, I would actually have to plug that number in. So that's 18,000 plus 1.2 times 10,000 all over 10,000. So I'll use my calculator in a second. And it asked me about 15,000, so that's just plugging 15,000 in. Plus 1.2 times 15,000. Now divided by 15,000. So as I go through that, I would recommend that you pause, go ahead and calculate those on your own, and then check your answers against mine. So I'll type them in real quick. Okay, I got $3 for the first one and $2.40. So again, getting smaller as I make more CDs, which makes sense, right? I'm approaching this asymptote of 1.2. I have $1.20 per CD. And so the fixed cost of 18,000 gets split up more and more over more and more CDs as I do 10,000, 15,000, etc. So that answers number 5. And then 6, if the studio wants the average cost per CD to be $2, how many CDs must they make? This is a great question because now I'm working backwards. $2 is my A of X value. So I know $2 goes in for that, and I'm solving for X out of this 18,000 plus 1.2X over X. So again, how do I solve a rational equation? Going back to FT5. I'm going to clear the denominator by multiplying by X on both sides, multiplying by my denominator. That gives me 2x equals 18,000 plus 1.2x. I can subtract my 1.2x. 0.8x equals 18,000. And then I can divide by 0.8 to get how many CDs I need to charge only, or it would only cost me $2 per CD. So 18,000 divided by that 0.8. And I wind up with 22,500 CDs. If I produce that many, it's only costing me $2 per CD. Okay, so that was number 6. And then 7, what meaning does the horizontal asymptote have in the context? Again, so $1.20 is the amount it costs to make each CD. That's the variable costs that I can't lower anymore. The fixed costs, that initial production, having people record it, those are set in time, but the $1.20 kind of represents how much it costs to keep printing the CDs, the materials to put into it, so to speak. I don't have to pay the musicians anymore for their time, but I do have to pay for the actual material that goes into the CD, the packaging, etc. So that's that 1.2, that horizontal asymptote, that average cost is approaching as you go off to infinity. So again, good chance to revisit some of the stuff we see before in 27.3 and even in 27.1 lessons as we introduced rational expressions. I hope you've enjoyed Unit 5. And looking forward to seeing what you can show me that you know next week. Have a great day. Let me know if you need any help.